My name is Eliana Strauss, and I'm presenting with Grace Tully. Here is our project, Bioprinting Bone Tissue. Bioprinting is a method of 3D printing that uses cells, scaffolds, and biomaterials to create three-dimensional tissues. Large bone defects impact the structural integrity of bone tissue. Bioprinting can allow a scaffold to be inserted into the bone tissue with the patient's own cells, allowing the bone to regrow without a high risk of immune response. This project is aimed at creating a 3D scaffold for bone tissue that completes both structural and functional tests with cells printed on the structure. It is hypothesized that through using an electrogel solution in the structure, bone will heal faster due to increased electrical stimulation. We started by testing various different scaffold structures with Vaseline. For materials testing, we tested the electrical stimulation levels on prints along with the structural integrity and found that a 2-to-1 Vaseline electrogel ratio was the best material.
After confirming this 2-to-1 ratio, we began the next stage of our experiment, printing cells within our structures. To remove any manual intervention, we loaded collagen into the bioprinter to create a base layer initially. Once the collagen printing was complete and had sufficient time to adhere to the petri dish, we introduced the solution containing dead cells into the bioprinter and printed them on top of the collagen layer. The final experiment consisted of connecting the function generator to both sides of the Vaseline structure to stimulate the cells. 5 volts were supplied to the structure for approximately 8 hours before observing the change in morphology of the cells. In order to sustain the cells, the petri dish was filled with media. 24 hours after the electrical stimulation, there was a visible amount of cell death. The Vaseline structure itself, due to sitting in the media solution, lost some of its strength, enabling bits of Vaseline to enter the cell solution. Our hypothesis was therefore shown to be false, since there was a decrease in cell growth post-electrical stimulation. For more details on how we completed this project, you can read our project report. Thank you.